Hi everyone. Now, if you've already decided that nuclear power plays no part in a low carbon future, you are going to hate today's guest. If, on the other hand, you're open-minded, or if you believe that nuclear does have an important role to play in the future of the global economy, then we're in for a treat. My guest today is Kirsty Gogan. Kirsty is a renowned expert on all things competitiveness, nuclear power, science, and science communications. She runs a company called LucidCatalyst, which is one of the world's expert consultancies when it comes to the cost of nuclear power. She's done work with ARPA-E, the US agency charged with accelerating the next generation of clean energy technologies. She's worked with the Energy Technologies Institute. We'll hear about that, no doubt. She's also chairs a working group at the UK's NIRAB. That's the body that looks after nuclear innovation in the UK, working on the cost of future nuclear power. And she's also the founder and still leads something called Energy for Humanity. So with that introduction, I'm going to pour myself a beer and we're going to bring Kirsty Gogan into the conversation. So Kirsty, cheers, welcome to Cleaning Up. And to get us started, you are one of the world's leading advocates and analysts of nuclear power. And so I was wondering if you could give us the elevator pitch for nuclear, just a short, punchy explanation of why you think we have to have some level of nuclear in a low carbon future around the world. Go.
It's the missing link to a livable climate.
Well, that was a very short elevator ride. I didn't even have time for a sip of beer there. Yeah, you need to expand on that and explain why is it, okay, it's the missing link, but the link between what and why is it so essential?
Great. Okay, so we have emitted half of the emissions that are currently in the atmosphere today in the last 30 years. Right? So despite, 30 years of really successfully building public and political support for action on climate change, driving down costs of renewables, increasing rates of deployments of renewables, we have still continued to emit really unacceptable levels of carbon into the atmosphere today. And now we have another 30 years to turn the tanker. And right now, if you look at all of the mainstream projections for 2050, whether it's the IEA or the EIA or DNV or BP, you name it, they're all projecting more than half of our primary energy coming from fossil fuels by mid-century. Now that means that not only are we not on a path to 1.5 degrees or 2 degrees, we're probably on a path actually to 3 or 4 degrees of warming. And that's why I think it's time for us to expand our attention to the other low carbon technologies and apply the really successful learning that we've really, we've established in the renewable sector to other low carbon technologies. So I'm not really a nuclear advocate. Actually, the reason I go on about nuclear energy all the time is because it's incredibly neglected. And because actually we really ought to be thinking hard about the contribution that it could make and what it would take to realize that value.
Okay, so there's a lot going on there. Thank you very much. You used a phrase which I normally jump all over, which is primary energy. And of course, primary energy, fossil fuels.
I agree with you.
2/3 of it is thermal waste from fossil fuels.
Yeah.
So it's kind of, but I'm going to let you get away with that because otherwise I know we'll go off on this sort of magnificent rant about primary energy. So let's stay focused on nuclear. And certainly, I've written about how you have to kind of be surgical and you have to differentiate between existing nuclear, which is kind of cheap, to keep running, and building new nuclear using the existing technologies, or trying to leapfrog to next generation nuclear. And I sort of say we have to keep the existing, we have to forget the existing technology to build new using the existing technology. It's kind of been tested to economic destruction, but that we should contemplate potentially leaping to the next generation. So
Okay.
Do you agree with that broad picture, or is there anything you want to sort of pick holes with right there and then?
Yeah, so I think let's spend a bit of time on the conventional gigawatt scale nuclear as we know it. Through the course of the conversation, I'm sure we're going to come back to that. I don't think we should write it off, and I don't think we should base our perceptions of that gigawatt scale conventional nuclear light water reactors on a very small sample of first of a kind projects in the United States and Europe today, because actually they're not really representative of what that technology can deliver. So I'm going to just leave that there. And then I'm going to say, actually, if you remember when I said that half of our energy, and you're totally right, if we electrify, we can massively reduce, we can be much more efficient. But nevertheless, we're seeing very large amounts of fossil fuels still being projected into the system by 2050. And a big piece of that is oil, is liquid fuels, it's heat and transport and industry. And for those sectors right now, we do not have credible, believable, achievable, cost-effective pathways to decarbonize. And that's where nuclear technology, which is very separate from the industry, nuclear technology could play a potentially really important role, because it creates high temperature heat, potentially very low cost electricity, and we can use that heat and power not only to generate power to support renewables on the grid and supply heat for industrial processes or district heating, but also potentially to actually make clean synthetic fuels and hydrogen, which we really, really need in those hard to decarbonize sectors.
Okay, so let's try and break this up into smaller pieces, because there's, that's a great pitch, and but it encompasses everything from heat to liquid fuels to everything. So let's try and break it up. So first of all, I think we can move on from keeping existing nuclear power stations open. I mean, there are those people, and we may have time to come back to what would you say to German environmentalists who want to shut nuclear before coal-fired power stations. But certainly you and I are going to agree that that's a funny breed of environmentalists, given the damage that does. But you said we shouldn't turn our back on the current generation, and you meant we should potentially be building more of them. And then you said something which is quite provocative, which is that these are first of a kind, and it's a small number of some. I mean, it's not. These are proven technologies. We've built a lot of them, or very similar in the past.
Yep.
And it's not like one or two projects went wrong. Every single project went wrong. Olkiluoto, Flamanville, Hinkley, Vogtle, or however you pronounce it. The Sumner plant, which was abandoned. I mean, these things are, it's kind of, if I paraphrase, I think it was Oscar Wilde, who said about Queen Victoria's prisoners of war, but I'll paraphrase it for nuclear. If that is how the nuclear industry treats its projects, it really doesn't deserve to have any, does it?
Yeah, they're all a set of first of a kind projects, first in a generation, right? So, what we've seen is a gap of decades since we built such a major piece of complex infrastructure in any one of those countries that you just mentioned. So they're first of a kind designs, in a generation, and the result of that is it's really straightforward. Actually, it's very understandable, which is that you have to, in order to get those first projects built, you've got to complete the design, you've got to get it licensed, you've got to engage with the regulators, you've got to get the supply chains qualified, you've got to train the labor force, you've got a really inexperienced project leadership, and all of that contributes towards, like Olympic scale, really difficult mega projects. Now, weirdly, very sort of, counterintuitively, the best thing that you can do when you've had an experience like that is immediately build another one, because that's what we're seeing in the majority of new build construction around the world today, and historically even in America and in the United and in Europe. We're seeing that once you've built that first one, once you've made that investment and you've established capability across the board, across labor force, project leadership, supply chain, and so on, and you've got a finished design and you build exactly the same one again, you can achieve a really dramatic cost reduction for the second project that you build, so long as you sequence across that learning. And we're seeing that again and again in programmatic fleet build approaches, which doesn't have to mean tens of gigawatts. You can even see a fleet effect now at Hinkley that we're building 2 units. The second unit is like 75% improvements on installing the rebar.
But Sizewell C, which is now being promoted, is only going to be 20% cheaper than Hinkley. So at the same time as we're learning a little bit, and we're going to apply that, Hinkley's costs have gone up again. So, and you say that, we've seen this time and again. Where have we seen it? Where in the nuclear industry have you seen programmatic build? Not talking about the 1970s. I'm talking about some time, any time in the last, 30 or 40 years. And I just, I'm finding it, this is going to be an interesting conversation because I'm pro-nuclear, as you know. I've signed your letters, I've supported what you do.
I know.
But, this stuff is miles off the pace economically, and it ain't getting closer, is it?
Right. So, it's so there's two things. Okay, I'm going to start with 2 ideas: the cost of capital and the capital cost. And our dear colleague Tim Stone, he said there's only 2 things that matter: the cost of capital and the capital cost. Right. I care a lot about the capital cost. And the cost of capital is important too, and I'll come back to that in a second. But actually, I want to see the industry step up and deliver, but better, right? And so I don't think the government ought to make funding available, financing available. I don't think the government should be reducing the cost of capital until the industry has demonstrated that it can actually reduce the capital cost. But the good news is that there are very credible pathways to reduce the capital cost. We published a report a couple of years ago for the Energy Technologies Institute called the Nuclear Cost Drivers Study, which then led to this helps inform the MIT Future of Nuclear study, the recently published Energy Systems Catapult Nuclear for Net Zero, the OECD NEA report that was published a couple of weeks ago. There's now quite a good evidence base, quite a good lot of literature around this question about what drives the cost of nuclear. And it really is like, when we started, it was like a black box with a big number written on it. And you'd go into Treasury and you'd say, actually, there are plants being delivered around the world today for half or even a third of the price than the costs we're seeing today in Europe and the United States. And they're saying, well, why is that? Is it because labor is cheap in China? Is it because they're cutting corners on safety? We look out the window and we see Hinkley and we say, nuclear is expensive and slow.
Kirsty, if you let me come in there, I love what you've done, separating the cost of capital from the capital cost. And let's get on to capital cost in a second, but let's just illustrate the impact of cost of capital. I mean, Hinkley, which is just, it's still being built, right, in the UK, the cost of electricity, £92.50 and that's in 2012 money. So in today's money, that's actually £110 per megawatt hour, $140 per megawatt hour, right? And you've got to compare that to, offshore wind, which can be done in the UK for about $60, onshore wind probably for about 35 or 40, the cheapest solar in the world, 15, 16, the cheapest wind is 20. I mean, it is way off the pace, way off the pace. And that had to be guaranteed for 35 years. But a big part of the reason is to do with the cost of capital, not the cost of just building it. So that the build is about 22 billion pounds, but the total cost of electricity in real terms is about 97 billion pounds because of the impact of cost of capital. So I think you're absolutely right to separate the two. But let's get back to the capital cost. And I want to bring in the work that you did for ARPA-E, because you put a number on it for the US, didn't you? You said, this is what it has to hit on capital cost, just the capex cost for the nuclear power stations.
Can I respond to the thing about the...
Yes, of course.
Oh, really, just quickly, because this is really... So first, 2 things actually I just wanted to say in response to the comparison with wind and solar, because I really agree that we've seen really impressive cost reductions in offshore wind, and that actually that's a sort of a template for success that we can now transfer across to other technologies. And a big piece of what's driven the reductions in cost for offshore wind has been a really competitive procurement process. And as we move from sort of project-based approaches for nuclear to more product-based manufacturing approaches, we should start to see similar trajectories.
But I'm going to
sector.
but we're talking about the big mega projects.
Yeah,
Now,
so
we'll get on to the programmatic stuff, and I agree there may be opportunities there for some different dynamics, but right now we're building massive projects that are producing power that is 3, 4, 5 times the cost of wind and solar.
Yeah.
And part of it was the capital cost, and part of it was the capex cost. So, you know,
and the
just
cost of
help us
capital,
to understand that.
the cost of capital is like 9-10% for Hinkley. It's extremely high. If
Insane. This was the stupidest possible way of funding probably the stupidest project.
Yeah, and you've heard me say, you know, I don't think governments should sign up to financing agreements without really clear commitments and demonstrated application of best practices to drive down the capital cost of nuclear plants, and that then actually they should benefit from.
Okay, but so let's come back. How far down do they need to be driven, though? Because Hinkley's capital cost, it's not the cost of capital, but the actual capital cost now is $9,300 per megawatt of capacity. 9,300. Now, what's the number that it has to be able to hit to be viable?
It's fair to say, for 3.2 gigawatts of, you know, 95% capacity factor power that will probably generate for 100 years. So, you know, we've got to sort of remember here that there's a good value proposition, and it's going to avoid millions and millions of tons of CO2 every year and support our grid, you know, forever. But if Sizewell C, which has now been very de-risked, because a big piece of this actually is construction risk. That's a big part of what drives the cost of capital, of course. So if you have basically eliminated very large amounts of construction risk as you go ahead to build the next project, which is essentially a replica of the first one with the experienced teams, and if that project was financed in the same way that, say, transmission lines are financed, like through a regulated asset base or whatever, then Sizewell C would come in at around £40 a megawatt hour, which is really, you know, pretty comparable to the prices that are.
But I'm pushing you on the capital cost, because I tell you what, the number I'm after is the number in your ARPA-E work, which is $3,000 per kilowatt. Okay, so you've got Hinkley construction cost at 9,300.
Yeah.
You've got what you need to hit is 3,000, and Sizewell C is only 20% better than Hinkley. Sizewell C is also going to be around the sort of 20 billion for 3 gigawatts mark. So I don't know where the £40 comes from. And obviously some of the improvement is going to be the cost of capital factor, but we're just, you know, you need a 70% reduction in the cost of building, and we're getting a 20% reduction. So, I mean, I'm just, and that, by the way, is if there are no cost overruns and no project overruns and cost overruns. I mean, is it really credible? Are you really saying you believe that can be done?
Well, so, okay, with the ARPA-E study, where we derived a maximum allowable capital cost for advanced reactors, which are much more manufactured products compared to these big constructions that we're talking about here. But anyway, we didn't say that this is what they can cost or how they will cost this much. What we said is this is what they have to cost if they're going to be useful, competitive.
Agree, but why would they have to cost a different amount from a gigawatt scale reactor?
We were looking at 4 ISOs in the US in 2034, which we picked as a kind of date that's somewhere in between now and 2050 and when we're expecting these advanced reactors to be commercialized. So what we're doing was trying to sort of inform upstream design decisions by these reactor developers to design for really well-defined market requirements. And the 2 really critical market requirements that we focused on were, first of all, cost. What do they need to cost in order to play in markets that have really high penetrations of variable renewables? So we're talking about really tough markets with, you know, energy prices of around $30 per megawatt hour. So, you know, very competitive and less. So that's what they need to hit if they're going to compete with combined cycle gas turbines, frankly, because actually all of the scenarios that we looked at that are developed by NREL, the National Renewable Energy Lab, high penetrations of renewables in the 2030s and actually all the way through to the 2050s, still have a lot of gas on the system.
Okay, so you're making a strong argument that these massive gigawatt scale plants can somehow magically be built for a half or a third or some large number of the price of a Hinkley or some of these projects that have gone wrong. And I guess I'll just have to remain skeptical on that. Now, in that world where you've got it down to, whatever, whether it's, the point where it's viable, whether it's $1 or $3 or whatever, I was just using your number there.
Yeah.
What job does it do in the, particularly in the, I want to know about the power system. I hear about, desalination and hydrogen, all those in the industry and so on. We come on, and those are the areas I think that are probably the ones, if nuclear is going to find a role, I suspect it's going to be there. But you think it's going to be in the power system. And I want to know what job it does in the power system of the future.
Yeah, well, so I agree with you that I think actually the most interesting application, the most interesting market application and value proposition for nuclear is outside the power sector. We're pretty good at decarbonizing the power sector. I see a role for, like in our ARPA-E study, we identified a useful role for products that can meet those cost targets of $3,000 a kilowatt, combined with thermal energy storage, 12 hours of thermal energy storage, enabling dispatchable load following to support really high penetrations of renewables on the grid, whilst delivering, full decarbonization. Because otherwise, all of the models currently project a role for gas in meeting that dispatchable need. So until we get some good storage, that could be a good option.
Your figure there, the sort of the $3,000, is based on effectively less than 50% capacity factor. Is that right?
No,
so you would run it for less than 50% of the time, and
combined with thermal energy storage, you can. So
you would run them. You'd run them 24/7, but then use what, molten salt or something like that to store the
energy? We used hot bricks, which is based on a Charles Forsberg's MIT work.
Right.
It's very cheap, and you essentially have a 12-hour thermal energy storage, and that enables you to pretty much load follow quite nicely on the grid. So either you're charging the battery. We also put 2 turbines on, so you can be using both. So you can actually increase the output and overall end up with like a 94% capacity factor for the plant. So it's good economics. It's good for the grid. You just have to hit the cost targets, which is going to be challenging.
It's interesting. I don't know if you spotted that I've become an advisor to a advanced geothermal company. One of the really cool things about EVA is that you've basically got an underground, you build a big underground radiator, all closed loop, so no fracking, no nasty stuff. Yeah. But what you do is you double size your generator.
Exactly.
So when you want to turn down, you're still getting the heat out of the earth, but you're just not generating. And then when you want to generate again, you just double up, and you've got 2 generators going at once, and you can do that for 12 hours. And so it's dispatchable. So it sounds like you're talking about a similar sort of operating profile there, which is definitely of interest, and definitely would be a good job within the electrical. And it's a job that needs doing, providing that sort of power.
Exactly. It's elegant, and actually geothermal
because one of the things that it doesn't do is it doesn't get you through, it'll get you through a night or through a daily fluctuation, but it won't get you through a week or 2 with no wind.
Yeah. So, it doesn't do the seasonal storage piece. That's a different issue. But nuclear can, of course, generate all the time. So, you still got the option of the base load, but what we've done is try to accommodate the fact that we need more variable supply into the grid.
Yeah. And I think there's lots of interesting work being done. Jesse Jenkins I think it's at Princeton, also doing lots of work on how much nuclear can cycle, because the conventional wisdom, the meme is, well, you have to run it 24/7. That's not actually true. You can cycle it a fair amount, but not, you do shorten the life and increase the maintenance cost to a certain extent.
It's not economic. The nuclear plants can run all the time, so of course they want to run all the time. But
and that's what I push back against, because you get a lot of the sort of the nuclear, I don't know what to call them, stands, the fanboys. You're different, and you're not a stan or a fan, but mostly on Twitter, you get guys who are determined that nuclear is the answer. And the reason is, they say that it is that it will fill in for variable wind and solar. And of course, what they're postulating is a nuclear plant that sort of does nothing when it's windy or sunny, and then is only used for a few hundred or maybe a couple of thousand hours a year just to fill in. And of course, that would drive the cost of nuclear through the roof if it wasn't there already.
Yeah, so capacity factors, let's bookmark that, because capacity factors are really interesting, particularly when it comes to dedicated hydrogen production, which is going to be what we'll need. But before we, I want to stick to this power sector contribution actually. And I think both geothermal and nuclear energy have a really interesting sort of unique mission, that is that they could repower coal. Now, I think that either geothermal or nuclear could potentially be repowering coal. And
you say repower meaning using the same turbines.
Yeah, so Fatih Birol of the International Energy Agency, when he launched the World Energy Outlook in December 2019, one of the three key priorities that he identified was legacy coal, was the fact that actually the global coal fleet is getting younger. Now in the UK, we're celebrating today the fact that we've got an equivalent amount of coal on the system as we had in 1769 or whatever it is, and that's incredible. And we could easily get the impression that we're succeeding in phasing out coal, but in fact the reality is that many countries are still building new coal, because actually energy means prosperity. And one of the things that we don't do very well when we're thinking about our climate mitigation strategies is the need for rising global energy access. And we have to really factor that in. So we not only have to decarbonize our existing fossil fuel infrastructure, but maybe double or even triple it to meet rising global energy demand. It's crazy to think that we're just going to switch those coal plants off, right? They're not just generating power, they're generating prosperity. And all of the investment in the assets, the transmission, that infrastructure, the socioeconomic benefits that it brings is going to meet a lot of resistance if we just assume that we can just switch it off. So the opportunity to repower, so in other words, to provide an alternative heat source for those coal fleets, I think is something really interesting that we should explore. And it's one of the kind of important attributes of both geothermal and nuclear.
Yeah, I hear you. I'm skeptical because what you do is you replace your older coal first. So if you go through a 30-year program of shifting to clean energy, then by definition in the last sort of 5 years, those plants are 25 years old or more. And so I'm not as convinced as probably as you'd like me to be, that we'll be sort of splitting the coal-fired power stations in two, get rid of the coal and the boilers and whatever, and just put a new heat source in. And geothermal, that will work if it's conventional, flash geothermal, but it doesn't work for any of the lower temperature stuff. So I think I've seen that increasingly surface as an argument for nuclear power. And of course, we're going to get on to some of the other sort of challenges of nuclear. You talk about, we're going to use nuclear, we've got to do energy access. So you seem to be postulating that nuclear is a fantastic technology to bring energy access to places like the Yemen and South Sudan and Niger and Mali, and which is and I'm more committed than the average person to getting energy access to those places. I'm just not convinced that nuclear. I want to come back. I don't want to jump around too much. I want to come back to you talked about capacity factor. You bookmarked it.
Mm-hmm.
So explain why you wanted to come back to it.
Oh, well, we've been looking at cost drivers for hydrogen production. And what we found is that capacity factor is probably the main one, right? So what we've looked at are the potential for clean hydrogen production from a range of different technologies, and capacity factor just stands out as being the critical piece. So even if you get your capital costs down extremely low for your electricity generating infrastructure and even your electrolyzers, and you improve the efficiencies of the electrolyzers, actually if you have got still a low capacity factor, you're still not going to be able to achieve very low. And just to give you a sense here, we need hydrogen costs to get down to at least below $1.50 per kilogram if we want to use the hydrogen as feedstock for ammonia production, which we can use in shipping and diesel engines and so on. And we have to get even below $1 if we want to use it for synthetic hydrocarbons. So we need really low cost hydrogen.
Yeah, and I agree there. And you're talking there about the capacity factor. I'm just going to sort of gloss that because not everybody in the audience will know exactly which capacity factors, because there's the capacity factor of the power source, but here you're really talking about the capacity factor of the electrolysis and the compression and all of the other things that you have to do to produce hydrogen, right?
Yes.
So, and here I 100% agree with you that, if you have nuclear stands saying that nuclear would be marvelous backup for intermittency, which is rubbish, but then on the other hand, you get this kind of, we get the stands on the other side saying, oh, well, we're going to use excess renewables and use it to power electrolyzers and make hydrogen. You're like, wait a minute. So you have wind and solar that might have let's say 20 to 40% capacity factor, let's call it 20 to 50%. And you may be wasting, let's be really, really bearish about the flexibility of the grid. You may be wasting 20% of that. So basically you've got about 5 to 15% of the time, maybe 5 to 10% of the time, you've got electricity excess, which you can then dump into hydrogen. And that's supposed to justify building massively capital intensive electrolysis equipment. It doesn't begin to compute, does it?
No, it's a fraction of a fraction. And
exactly.
It might be worth you investing if you wanted to do something with your, so we have depreciated PWRs in the United States that are looking at hydrogen production because they're having to, turn down all the time because the grid is now has other generators on the system. So fine, do that, but that's not going to deliver either the scale or the costs that we actually need to address the liquid fuels markets, which are maybe 4 times the size of the electricity market.
But I think your competition there is not excess peaks of curtailed wind and solar. I think that your competition there is in those locations where you've got, let's say, $20 wind, $20 solar, either co-located or connect them via high voltage DC. And then suddenly you're going to get to 60, 70, maybe even 80% capacity factor for electrolysis. And by the way, I agree. I think the target is $1. It's $1 a kilo for the hydrogen, maybe even 80 cents.
Yeah, we have 90.
I'm pretty sure we will get there using renewables by 2040, or take a couple of decades to get the renewables costs down, the high voltage DC costs down, and the electrolyzer costs down, and maybe, by the way, desalination, because you may not have water exactly where you've got all of the sun that you need to do that. But we're going to get there using let's say 60 or 70%, probably 70% capacity factor of very low cost renewables, and I think that's the target that you've got to shoot for.
Yeah.
And
well, I have a few comments about that, and I think you're right. I think we have wind and sun combined to achieve higher capacity factors, like Western Australia. There's
North Africa.
And as you say, this seems
parts of China, parts of India, parts of the US.
Yeah, indeed.
Mexico, some parts of Latin America.
There's some good consensus that those costs could be achievable as soon as the 2040s. And that's great, and we should completely do that. I would say that I started out by talking about the importance of the next 3 decades, and if we can do something sooner than that, then why wouldn't we?
Because we haven't got the nuclear costs down yet. I mean, in a sense.
So renewables didn't start out cheap either. They got cheap through a really intentional, deliberate, concerted, coordinated effort to make them cheap. And by moving towards those modern, high productivity manufacturing environments and product-based repeat build approaches, why wouldn't we apply that same success template to other technologies? And let's face it, there's a lot of potential for cost reduction in nuclear. It's one of our favorite jokes in our organization.
That's what's known as a backhanded compliment, I think.
Yeah.
Let me if I might, I think that the secret weapon that nuclear has got in whether it's electrolysis or other parts of industry and chemicals, is heat. It produces high quality, high grade heat,
Yeah.
which of course wind and solar don't do. And even the advanced geothermal that I'm now a huge fan of, that also doesn't produce, it produces heat, but maybe only at a couple of 100 degrees and not higher. And it strikes me that the sweet spot, instead of fighting the battle, to be intermittent and to load follow and to do really complicated things, to go to industries and sectors that need 24/7 power plus high grade heat. And there's so many of those industries out there that why would you need to address a bigger market than that initially to drive yourself down the cost curve?
Yeah, I think the heat applications are interesting as well. For me, it's sort of fuels production, and the fuels production opportunity, especially if you apply that high temperature heat to thermochemical electrolysis, which is emerging as a technology, and it's being demonstrated in labs, but has a lot of potential to be very, very efficient and reduce costs even further. It really puts you into, combined with shipyard manufacturing and thermochemical heat, you really get very quickly, we think in the early 2030s, into that less than $1 per kilogram range for hydrogen, which gives us a head start. And the beauty of it, just like being able to go to those remote, windy, sunny places for renewables and making fuels, is that you're not constrained by your location when you're making commodities for export into global markets, in the way that you're constrained by your location when you're making electricity and you're tethered to a power purchase agreement, which takes 30 years to pay back and depends on the sort of scale and reliability of the consumer to support your investment. If you can actually build anywhere, because you're making fuels for export into global markets, and build really large scale projects. So, we have a hydrogen gigafactory concept, for example, which is 30, it's a refinery scale project. You can do that when you're making fuels, and that way then you also get into that economy of scale, justifying the investment in the factory.
Kirsty, if I might, let's now move on from the economics of nuclear power, because there are lots of other objections that people raise. And what I want to do is I want to raise them so that you have a chance to knock them out of the park, because I suspect that's what you'll want to do. So I'm going to push you, but I'm sure you'll be able to answer, in kind. Nuclear's just not safe, is it? What we've seen is one major accident every 20 years since the technology was first used. We've seen Windscale, 3 Mile Island, we've seen Chernobyl, Fukushima, and when things go wrong, they don't go a bit wrong, they go horrendously wrong. And they cost hundreds of billions of dollars or more, and it's always the state that has to step in to sort things out. I mean, that's pretty damning, isn't it?
Yeah, I mean, why is it that people think that the safest form of electricity generation is the most dangerous? And my theory is that because the industry has spent decades persuading everybody about how incredibly dangerous it is. And that isn't only in the communications, like constantly, marketing itself on its safety record. Imagine if an airline, was advertising itself because its wings hardly ever fall off. Would you fly with the safest airline? Actually, of course not. There's a complete confusion within the industry between internal professionalism and quality standards, and its external messaging. And actually, its track record is, you can see for yourself, look at the evidence, it's the safest form of electricity generation. And yet we have...
You've said that a couple of times. I think what you're talking about is over the megawatt hours, the terawatt hours generated, the sort of accident or the numbers of deaths is actually amongst the very lowest, not the highest. Is that what you're referring to?
Yeah, I mean, if you look at the per terawatt hour, then yes, it's invisible. And that's taking into account all of the big accidents. And this is for two reasons. It's partly because actually all the other energy sources do contribute very severe public health impacts, especially coal and gas. Of course, we have 7 million premature deaths per year from air pollution, indoor and outdoor air pollution, largely from fossil fuels.
But you're not going to fix. You're not going to fix. I mean, there's a whole bunch of those to do with indoor cooking.
Mm-hmm.
Right? Nuclear. Yeah. Are you going to suggest that in the developing world we should, power all the, we should have electrical cooking within the next 20 or 30 years using nuclear power? Is that the solution?
Yeah, well, actually, yeah, the public health impacts of a lack of access to electricity, why not look at all of these risks in the context of the material risk of climate change, the material and severe public health impact, particularly impacting women and children, on the effects of having to use smoke.
All of which I've done lots of work on. I couldn't agree more. But you're postulating nuclear as a solution to people who are incredibly poor. They're on a few dollars a day, and they're out in the middle of nowhere in many of them unstable. And one of the reasons why they're so poor is because they're politically unstable countries. And you want to come in and build nuclear. I mean, come on, that's really not going to happen, is it?
Yeah, one of the things. I mean, one of the things actually that I'm really interested in is the potential for using high temperature heat from nuclear technology to produce clean synthetic fuels that could be imported into developing countries. Kenya, for example, spends $1 billion a year on oil for its distributed generating capacity. Why not switch out those dirty, volatilely priced fuels with clean alternatives? So we're not talking about necessarily having to build, nuclear plants in countries that don't have mature regulatory capability and supply chains to build, maintain, and operate nuclear plants. I'm talking about a much broader system-wide perspective. And just to sort of jump back for a second to the sort of Chernobyl and Fukushima, absolutely terrible public health impacts, but actually the World Health Organization and the United Nations have concluded that by far the main public health impact caused by those accidents was actually fear of radiation, not radiation itself. In fact, more people died in the Fukushima prefecture as a result of the evacuations and the reactions of dislocating hundreds of thousands of people, destroying tens of thousands of people's lives as a result of fear of radiation, whereas actually the radiation itself had almost no public health impact at all.
But it's a bit mean of you to blame the industry for that, as you did, because I had a bit of a run-in a couple of years ago with a chap called Rudolf Rechsteiner. Now, he is a Swiss member of parliament. He is the chair of one of the leading, in fact, I think in Switzerland, maybe the leading sustainable investment platform, something called the Ethos platform, Ethos Foundation. He's a lecturer at ETH. He's a lecturer at the University of Bern, and he tweeted this: Chernobyl, more than 1 million dead. Don't repeat mistakes you can avoid easily and cheaper and faster. What do you say to a Mr. Rechsteiner who is propagating a figure of 1 million dead from Chernobyl?
I mean, it honestly really upsets me, this kind of fear-mongering, because it causes enormous distress and actually contributes towards the mental health and real public health impacts that we've seen and we continue to see to this day in affected regions, where people are so afraid that their lives are often destroyed as a result of the fear and for what? For ideological point scoring. I used to be, as an environmentalist, I was always anti-nuclear, and I was called in by the government to evaluate the response to Fukushima. And I thought, well, I'll do this with integrity. First thing I did was read all of the Chernobyl reports from the World Health Organization, the United Nations, and I was shocked.
And what's the correct number? You've probably got it on the tip of your tongue. What's the correct number from the World Health Organization and the IAEA for Chernobyl?
Yeah, so, well, I think there's 57 deaths that are directly attributable to radiation. And that would include, there were thousands of thyroid cancer cases, and 99% of those were treatable and people went on to live their lives. There were obviously people affected directly during the accident itself. And then in addition, the World Health Organization estimates possibly up to 4,000 that they're sort of lost in the noise as a result of, some small increases. it's really tragic. And actually what that role led me to do was to revise the National Civil Nuclear Emergency Planning Guidance, which is probably the thing that I'm most proud of in my career. It's the thing that the fewest people will ever read. What it means.
Let me guess, it now reads, keep calm and carry on.
It says it broadens the assessment of risk, because humans are terrible at making assessments of risk. Yeah. We're much more frightened of getting in an airplane than we are of getting in a car. We're much more likely to die in a car. And so what we've tried to do is bring a little bit of rationality into our emergency planning in the UK, so that we don't actually end up causing more harm than good, trying to avoid what would otherwise be, relatively harmless amounts of radiation.
Okay, now let me just continue and with another. I think we've sort of, hopefully we've dealt with Mr. Rechsteiner and the others who think that this stuff is all, kills millions, and the facts are that that's simply not true. Nuclear waste. Look, the fact is, not one single country has got permanent nuclear waste storage. Not one. Finland's probably the closest, and that might be 2023. It's got this Onkalo repository. Yucca Mountain has been an absolute disaster. It's been 33 years in the discussion, doesn't exist. There's ponds full of this stuff. There's warehouses full of this stuff. It is going to be around, some of it, for 100,000 years. That's 100 times longer than there have been capital markets. You want this stuff to be financed at a low cost of capital, it better be, because you've got 100,000 years looking after something and you don't even know how you're going to start. You've not got a repository.
Yeah, we're really good at looking after it, actually. We looked into this last year in quite a lot of detail for the Sustainable Finance Taxonomy Technical Expert Group consultation. And they were like saying similar things like, oh, we haven't actually got a fully operational, demonstrated repository that's been operating for 100,000 years. So how do we know that it's going to work? And we looked for a single example of any harm that is being caused to people or the environment throughout the course of the entire civil nuclear, operation.
Okay, so that's the first 60 out of 100,000 years have gone well. The first 60 out of 100,000 years.
It does not, it will not cause harm to people or the environment. We're looking after it extremely well. There's repositories now that are planned in Finland and Sweden and France. Frankly, my opinion is that we're perfectly well able to manage what are tiny amounts of spent fuel, and that we should probably want to recycle that spent fuel in next generation advanced reactors as fuel. We use less than 1% of the available energy in the fuel, so we should hang on to it and use it in the next. It should be seen as a bank, of a fuel bank.
And sites like Sellafield or the one in France, I can't remember what it's called, The Hague. These are also banks. You've got this marvelous resource. We should be proud of it. It's all mixed in with the earth and leaching out into the rivers and sea, but we should be proud of it. Yeah. And by the way, the cleanup, you know this, the budget for the cleanup of Sellafield. Yeah. All of our all of our Bay's budget, some vast percentage of it, 70, 80%, 90%, whatever it is, is going to go on the Sellafield cleanup, right? Yeah. So, okay. 100 billion, 200 billion, I can't even remember. Yeah.
Cold War legacy. That's what that is. As I was deputy head of civil nuclear security, and I spent a lot of time investigating this issue at Sellafield, and I can tell you that lion's share of budget that sits right now in Bays is actually a defence legacy waste. It's about 75% for Sellafield. About 75% of that is for about 4 buildings in Sellafield. It represents a tiny, and it all dates back to the Cold War legacy, when we were basically fighting the Russians. Nobody was giving any thought to, how we were going to clean this stuff up. All they were doing was focusing on avoiding annihilation. It is not the same as civil nuclear waste. And the fact
you're telling me that the nuclear
industry has allowed it to be conflated, to me, is a scandal. This should be.
Let me just ask you though: are you going to guarantee that the same sort of sites are not the same processes. The same thing is not happening in the Pakistani nuclear program, the Iranian nuclear program, the Indian nuclear program, the Russian. Presumably, they've got the same. They've probably got much worse pollution from their Cold War activities. The Chinese nuclear program. These are all being run now with magnificent regard to safety, and no waste and no cleanup problem is being created currently.
Yeah, it's absolutely the role of regulators to properly oversee that and to make sure that those materials are being taken care of properly.
Okay.
And let me tell you that the most successful non-proliferation program that we've ever seen, called the Megatons to Megawatts program, was 20,000 or maybe more former Russian warheads that were disposed of in American nuclear power stations, supplying 10% of US electricity for more than a decade. It's, you know, kind of a poetic.
You raised the next issue, which is proliferation. I mean, it's very nice, and I've said that I think economically we could probably lower the cost of nuclear by building them in shipyards, building them small, build lots of them. And when we talk about small, we're talking about nuclear power stations down to 1.5 megawatts. There's a company called Okla. That's trying to develop a 1.5 megawatt. And the theory is, oh, well, it's so small, you can sort of put it on a truck, you can drive it around, you can put it somewhere, you can leave it unattended. I mean, come on. You know, this is a recipe for absolutely losing control of nuclear materials. Surely you can't argue that this is a sensible way forward.
Well, I think it really depends on on the nature of the product. And, this is why we come back to, again, designing for market requirements. I don't want to be sort of advocating for technology's sake. What I want to be advocating for are solutions that are actually designed for the markets they serve. And if we don't start doing that, if we don't have the nuclear industry start doing that, then they're not going to have a market. And what this proliferation risk that you're describing is real and has to be designed out. It's just as simple as that.
But the thing is that doesn't it also drive costs, which are then met by the state and not by the electricity producer? Because right now you can't insure. Fukushima may be much better had people stayed where they were. The fact is, hundreds of thousands of people displaced. Chernobyl, hundreds of thousands, millions of people displaced, and the costs always fall on the state. You can't get that insured. And then you've got the militarization of protecting the supply chain, all the way from upstream, the mining of the fuel, the fuel refining, the plants themselves, and then all the waste, all of it being protected on the public dime, none of it being paid for by the industry. How is that justifiable?
It has to be a combination of designing products that are fit for purpose, that are designed for purpose, that whose costs are fully internalized and not externalized to the state. I fully agree with you. And then we have to look at
any nuclear site in the world, and you'll find that the army or the militarized police is protecting it, right? Mm-hmm. Who's paying for that?
Yeah.
How do you avoid that?
Yeah, I think the light water reactors that we have today, flow from a military objective, which was to produce plutonium. And it's a very valid reason why, many of the Greens and so on object to nuclear energy, because they oppose that legacy. And I'm fully with them on that. But I think that these new advanced reactor technologies that are under development today are very different products. As our friends at Third Way like to say, this is not your grandfather's technology.
Right. So I'm a kind of believer, but without an enormous amount of basis of knowledge, that they are passively safe. In other words, if you just cut the power, you walk away, you inundate them with a tsunami, it doesn't matter, you're not going to get a meltdown or a leak. Is that right? Yeah,
I mean, the high temperature test reactor in Japan was pretty close to the Fukushima earthquake tsunami event. And it shut itself down and they all went for lunch. And after that, it was like that. It's this passive safety systems. It's a very, very different And after that, it underwent a really extensive regulatory review, and the whole thing had to be completely, evaluated against this newly understood risk and relicensed accordingly. And it has now been successfully relicensed and restarted. So yeah, there's real projects that you can go and look at. In fact, we're currently undertaking a due diligence exercise on exactly that project, with a view to seeing how ready that product might be, both for licensing but also in terms of supply chain and economics.
And a one-word question: thorium?
Oh. No thanks.
So that's very funny. That goes into the compendium of great answers. Another sort of one-word question, maybe: eco-modernists. What's with eco-modernists? Why do they seem to think that if you can just throw shade at wind and solar, that suddenly this tremendous nuclear build program will be unleashed and the world will spend, hundreds of billions and trillions of dollars building their favorite technology? What's going on there?
I guess it's technology evangelism, or it's.
But it's not. But no, because I like talking to you, because first of all we agree on everything except these big plants. But also you haven't said anything nasty about wind and solar, right? You don't try and do your job by disrespecting, by throwing shade at any other technology. So you're evangelizing. You are truly evangelizing. You put the positives of nuclear. You state your assumptions. You've just brought in another great advantage, which is that it's nice and compact. Fabulous. That's a very good point. You haven't said anything nasty. You didn't say nuclear is nice because it's much, because it doesn't disfigure the countryside and kill the birds and all the stupid things that they say. Why do they feel compelled to do that?
Yeah, this nuclear versus renewables thing is incredibly counterproductive, and it's something that I had the first time I met some people in the west coast of America. We spent the whole afternoon having a stand-up row.
Who was that? You want to name names? You should name names. Come on.
Well, it's in the history now, but
somebody who thinks there's no such thing as a apocalypse now, or whatever it is.
Well, it's just incredibly counterproductive, because actually what it misses the point of a values-based approach that informs most of the way that we think about things. We're incredibly rigorous about engineering and about science, and then we pay no attention, no rigor to the science of science communication. And actually what we really know is that if you go out attacking people that you're trying to persuade, what you're going to do is create a defensive reaction and further, entrench the original position that they hold. And what you're also doing when you're attacking renewables and advocate, my technology versus your pet technology, is you're confusing the means with the end. And too much of our climate discourse, I think, confuses the means with the end. We set technology goals instead of outcome goals. We need to define new success metrics, which are really all about the performance of the whole system. And what we know is that the fastest, most feasible, most cost-effective, most proven way to decarbonize is through a combination of nuclear and renewables. And guess what? People also like it. And there's lots of evidence to show really a lot of public support for a combination of nuclear and renewables.
So I couldn't agree more about the need to up our game on science communication and communication about energy. It just seems a really difficult thing to do. It seems that the less people know about energy, the more determined they are and the more forceful they are in their views, whether it's about how fabulous thorium is, or how awful solar power is, or indeed how awful and how dangerous nuclear power is. So we've got a lot more work to do. I think you and I, every day, we try to move the ball a little bit further down the pitch to do a little bit of that work. I suspect I'll be seeing you next again on Twitter, where I want to remind everybody about your bio, because I find it so fantastic. Do you have it off by heart? Can you give us your bio? Look at the camera and tell people what it is you do.
So at Kirsty Gogan, and I guess I wrote it in about 2014. Let's see: climate, energy, science, politics, mama, feminist. I should probably reorganize them in order of priority.
If I could, I would borrow that bio. I can't, but I've had enormous fun talking to Kirsty. Kirsty, thank you so much for joining us. And I shall see you again, no doubt, on Twitter and hopefully in person to continue this great discussion. Thanks for joining us.
Thanks so much. It's been a real pleasure.
So that was Kirsty Gogan. And you can see why she's one of the most powerful voices advocating for nuclear power, but doing it in a fact-based and incredibly sophisticated way, not saying bad things about any other technology, but always relentlessly promoting the values and benefits of nuclear power. Has she persuaded any of you? I don't know. I've no doubt we'll find out in the comments and discussions on Twitter and on the various platforms where you can watch this podcast and this interview. My guest next week is a very special person. She led the IPCC during a very critical period, from the failed COP summit in Copenhagen in 2009 through to the triumphant Paris COP summit in 2015, where the Paris Agreement was signed by all of the countries of the world. She did it with a relentless optimism, never taking her eye off the prize, never taking no for an answer. And those who know her were not at all surprised that Paris was such a triumphant occasion. She's also an incredibly nice, funny, human, and interesting person. Our guest next week is Christiana Figueres. I very much hope that you will join us for a conversation on next week's episode of Cleaning Up.